This video is for section 10-10 about complex numbers. Expressions in the form a plus bi, where a is a real number and b is a real number, represent complex numbers. A complex number will be one of these two possibilities. A complex number includes real numbers. And in the standard form, this is when the coefficient of the letter I is a 0. So if this is just a 0 right here, you don't really have to write 0i. And so your real number is given by whatever the value of a is. Real numbers would be like 3, 0, -0.5, decimal numbers, and so on. The second type of complex number is called an imaginary number. And it has this format, but the letter b is not a 0. So one example of an imaginary number is -2 plus 3i. This number in this format is called an imaginary number. It is not a real number. It cannot be located on the real number line. Imaginary numbers such as 2i or -3i, which have the form 0 plus bi or just bi, are called pure imaginary numbers. So a pure imaginary number is a number that has no real number component. It only has the part of the standard form that has the letter I by it. Here's an example. 3 plus 2i is an imaginary number, but not a pure imaginary number. Whereas this one here, 4i, that is a pure imaginary number. It doesn't have that extra real number term on the beginning. Here is the definition of what equality means over the set of complex numbers. These expressions are equal to each other only if the real number terms are equal and only if the coefficient of the letter I is equal. Here's a true or false question. 7 plus 2i is equal to this expression right here. Well, let's simplify on the right side. 3 plus 4 makes 7, and 8 minus 6 makes 2i, so would you say true or false? This is true. Here is the definition of what it means to add complex numbers. If you want to add this complex number plus this complex number, then what you do is you add the real number terms together and you combine like terms on the I term. Here's an example of this. Add together 5 plus 3i plus 6 plus I. Combine like terms. 5 plus 6 makes 11, and then 3i plus 1i. That makes positive 4i. So adding together complex numbers is really the same thing as combining like terms. Think of the letter I like it's a variable. The difference is that the letter I is not representing a variable. I isn't a letter that means fill in different possibilities. The letter I is actually representing a particular number. And the number that I is representing is the square root of -1. So I is not a variable, I is a constant number, and that number is the square root of -1. If you ever see an expression like this, a plus -bi, we can use the same rule that we learned about positive and negative numbers earlier this year and simplify it as a minus bi. And this indicates what subtraction is in the complex numbers. You follow the same rule as subtracting real numbers. Let's do some examples where we simplify complex numbers. This complex number plus this one. Give that one a try. This makes -1 plus 2i. Because -3 plus 2 is -1 for the real number term, and 6i and minus 4i makes 2i for the imaginary term. Try this next one. This time we have 5 minus 4, which is 1, plus 16 makes 17. And then for the I terms, we have 10i minus -3i, which is 13i, and then -i, which is positive 12i. 10i plus 3i is 13i. Take away I is 12i. Let's summarize the lesson. We discussed a new type of number called complex numbers. Complex numbers include the real numbers that we're very familiar with, but also a new type of number called imaginary numbers. And in a future section, we'll discuss why mathematicians needed to create imaginary numbers. But you can see where they come from right here. Imaginary numbers were created to deal with the situation of having the square root of a negative number.